Yeah, well, we had a few storms here and there, even a little bit of a downpour near the Broadway curve earlier this afternoon. And as these monsoon storms continue to fire up, we are working to make sure you get an early heads up before the storms strike. One of the best tools for predicting these monsoon storms is something you're only going to see right here on ABC 15.
From flooding rain to giant dust storms, forecasting the monsoon is one of the trickiest things for meteorologists to do. Unlike winter storms, we can't see them moving in from the west days in advance. They form day to day as our intense summer heat causes air to rise and the moisture in that air to condense into clouds. Many forecast models cannot accurately represent the role our smaller mountains play in causing our often isolated monsoon storms to form. But scientists at the University of Arizona have been leading the way to try to solve this problem and others to get us more accurate forecasts for years.
15 years.
Patrick Bunn runs the WRF model at U of A.
We run a 1.8 kilometer grid spacing in our model.
Futurecast from the University of Arizona model.
That's by far the highest resolution available, and ABC 15 is the only station to bring it to you. Each year, the scientists at U of A watch how the monsoon plays out and how well the model does to predict it. Then they get to work tweaking the model to make the forecast better and better.
For example, change the microphysics, so cloud processes, how they're represented in the model. We change the scheme during the monsoon season because one scheme better represents those cloud processes. And also now we use the high resolution rapid refresh model as initialization, and that has a sophisticated data assimilation process where it ingests satellite imagery and observations from the ground to kick off the model in the most close to observations way.
It's those ground observations that they need more of to make the forecast even more accurate. But for now, just knowing the strengths and weaknesses of the model can help forecasters like Tyler Mayo give the rest of us a heads up on how each day could play out.
There's certain things in the model that sometimes may be a little hard to understand, and what we want to do, like for example, the August 31st boob case last year. The model, the simulated reflectivity of the model actually didn't show anything making its way into Phoenix. However, if you looked at the model soundings and you looked at the wind field, that actually did show that there was a potential for outflow boundaries to make their way into Phoenix. And sure enough, I mentioned that in the discussion, and sure enough, a haboob made its way in there.
An early warning giving us all more time to prepare instead of react as monsoon storms impact our community.